talk about the law of sines, or sometimes it is called the sine law, or sometimes the sine rule. So what is the law of sines? What it is good for? What kind of tool it is in mathematics for us? The law of sines can be applied to find unknown lengths of edges or angles in the triangle. And it doesn't matter what type of triangle is it. We will be considering any type of triangle, not necessarily right triangle. And I will show you how, by applying the law of sines, we can recover unknown lengths of edges or angles in this triangle. So first, I would like to formulate for you the law of sines statement, and then we will consider some examples. So let's first consider the following triangle. So I will just sketch any arbitrary triangle. So this is my triangle, and we will be denoting the edges and the angles of this triangle appropriately. So let's go with capital letters A, B, and C, which will denote our angles of this triangle. And now we will denote the edges by the following. We will put the edge A, lowercase letter A, which will be the opposite to the angle A. So A lies in opposite to the angle A. Similarly, side B will lie in the opposite to the angle B, and then side C will lie to the opposite to the angle C. And now the law of sines statement can be formulated in the following way. So the A, side A, corresponds to the sine of the angle A exactly in the same way as the side B corresponds to the sine of the angle B, exactly in the same way as the side C corresponds to the sine of the angle C. So here we see that the A, which it's the opposite side to the angle A, its relation, actually the relation between A and sine A, is exactly the same as the relation between B and the sine B, and exactly the same as the relation between C and the sine C. So how to understand this equation here? So actually here there are hidden three types of equation, because we have two equality sign. So we have here three equations. And what are those equations? So actually these two double equality equation can be written in the following way. So you can understand it as the system of three equations. So we can just consider it pairwise. So here we have that A over sine A is equal B over sine B. This is the first equation. The second will be that B over sine B is exactly the same as C over sine C. And the third pair of equation will be that A over sine A is exactly the same as C over sine C, dear students. So this double equality above is equivalent to these triple or three equalities, three single equalities below, but they have to hold simultaneously. So that's why I denoted as a system. So they all have to be verified. They all have to hold, all three. And it's exactly the same as that double equality here. Okay, dear students. Now let me give you a short proof of this law of sines, so you will have the idea where do we get it, where do we get this statement. So I will show you where do we get it. So first, let me prove, I don't know which statement I will prove, but I will just use the approach number 1, or consider just the case number 1. And we will see which statement we will actually prove, which of these three equalities we will prove. So again, I'll just repeat, dear students, I'll just repeat my triangle here with all the same notations. It's important to keep the same, so we will exactly prove the statement we have in the beginning. So we consider this triangle, dear students, and now in this triangle we draw the height. the height h, I denoted by h, this height, and you always know that this height is perpendicular to the side to which it is drawn. So here, this perpendicularity property we denote by this right angle here, 90 degree. So now we have, let's see, maybe for convenience, dear student, we will also need to put capital letters A, B, C, and here D as just the to denote the vertices of our triangle. So we can now have this big triangle which we call ABC, and it's now is divided into two triangles, or it's like composed by two triangles. The one triangle will be ABD, and another one will be DBC. So now, dear students, let's consider triangle ABD. So in this triangle, we see that this is a right triangle because this triangle has a 90-degree angle. And here we can apply the sine definition, dear students, the sine definition for the angle A, because we already learned it. So we can write that the sine A, and by definition, what is the sine A? It is the relation between the opposite side and hypotenuse. And to be more precise, it is the opposite side over hypotenuse. So we see that opposite side is H here. So it's H, and over hypotenuse, it will be C. Now, similarly, dear students, we consider the triangle BCD or DBC. It doesn't matter. And here we will consider the angle. I have to write here the capital C, the sine of the capital C angle. And we see by definition of the sine function, what is the sine of the angle C? It's again the opposite side over hypotenuse. But in this triangle BCD, the hypotenuse will be A. So this is exactly what we will get. And now, dear students, by just applying very simple algebra, we can solve it for h, both of this equation, the first and the second, and we can see that h from the top equation is c multiplied by sine A, and from the bottom equation, h is equal to a multiplied by sine C. And so what did we get, dear students? We get that here on the left-hand side, we have the same HH, which means since the left-hand side is the same, it means that the right-hand side is also the same. So from this, it follows, dear students, that we have C times sine A equal A times sine C. And now, dear students, to get exactly the expression that we had above, we'll just divide this expression, this equation by sine A times sine C. So what we will get here, dear students, if we divide these both sides by that same expression, so I'll just write it here. So it will be A times sine C over sine A times sine C. We see that we have sine A in the top and the bottom, and then we have sine C in the top and the bottom. So what remains is the following. C over sine C is equal A over sine A. Very good, dear students. So let's see which equality did we get. We get C over sine C is equal A over sine A. So we got C over sine C equal A over sine A. So we got this third equality. So we verified it. Very good, dear students. And now how do you verify this equality and this equality? How do you verify it? We just consider two different cases, two other cases with drawing the height h in this triangle. So which two different other cases remains? It remains the following. One case is that you can draw this height h from the vertex C to the opposite side C. This is the second. And the third one will be when you can draw this height h from the vertex A to the opposite side A. And then you will get the first and the second equalities when you will be doing the same procedure as we did here for the first height case, you will repeat the same for the second, for the third, and you will verify this equation and that equation. And we are done. So this is the proof of the sign of the law of sines. Very good, dear students. Now let's check how it works on practice. So I have here the first example, which is very simple, and it just asks us to apply directly the law of sines to be able to find. Here I denoted by X the unknown side, because as I mentioned, the law of sines is applied to find the unknown lengths of edges in our triangle or unknown angles. So this task is about finding the unknown lengths of edge of our triangle. So let's see, dear students, what we are given. We are given here one side and the measure of the angle that lies in opposite to this side. We also are given another angle, its measure, and we want to find the side, the length of side that lies opposite to this angle. So, dear students, how can we apply this law of sines now? So we know that this side that lies to the opposite to its angle, and to be more precise, its ratio. So that side over the sine of the 57 degrees is exactly the same as this side over its the sine of its opposite angle. So it will be sine 42 degrees. So we got this equation and we don't need the third part here. So dear students, you have to be careful always, like which equation you need to use to be able to find your unknown. So you see, we have here's the set of three equations, but we don't have to use each of them, always three of them, always to be able to find one unknown. No, we just look what data we are given. And based on that, we just pick the first or the second or the third equation, just based on what we are given and what we need to find. So here in this case, in our example, we are given angle A, angle C, and we are given the side A, and we want to recover this C. So we have A and C just. So which equation corresponds to it, to A and C? Only this, because this includes B and this includes B as well, both angle and side. And we do not have B, and we do not need it because we are given A's and we want to find the C side. So we will be using the third equation. So this is how we got this third equation, dear students. And now we just solve it, dear students. How do we solve? We just multiply across these bottoms and tops. So we will get A times sine 42 degrees is equal X times sine 57 degrees. And now here to find X, we'll just divide both sides by sine 57 degrees. So we will get A times sine 42 degrees over sine 57 degrees. Very good, dear students. And you can measure it in centimeters. I don't know, it depends. Yeah, because that side was given to us in centimeters, so that value will give us centimeters. And you can use your calculator to find the sine 42 degrees and sine 57 degrees. These are not the standard angles, so you can use a calculator to find them and then find the approximate value, or maybe that will even give you a concrete value. I don't know, you should check. Then you just multiply by 8. And this is our answer, dear students. Now, let's consider another example, dear students. So here I have another type of triangle with the same given angles, with the same side given, but now we are asked to find not this side, which is very convenient, like you just directly apply the formula, but this is another side, and we do not have, by the law of sines, we need this opposite angle to be able to apply the law of sines to recover that y side, but we do not have it. But let's see what we can do here before we start applying the law of sines. So first, dear students, I will show you how to find this angle here. And it's very easy to do because we all know that the sum of angles in any triangle is equal to 180 degrees. So to find x here, dear students, we just take 180 and we subtract 57 and then we subtract 42, dear students. And then let's see how much that will be. Maybe this will be 81. You should check. It seems like it will be 81. So now we know, dear students, that this third angle here is 81. So now, dear students, we can apply the law of sines. But let's see which data we'll pick to be able to apply this law of sines. So we want to find y, so we need this opposite angle. Now let's see which other sides are we given. Are we given this side? No, we are not. So to use this angle is not that good. But we are given this side. So we will just choose this side and we are given its opposite angle too. So this green circle data is all the data that we will be using to find our y, like to formulate the law of sines. So let's do that. So we have that the side over the sine of its opposite angle, which is here 57 degrees, is equal to this side, this is y side, over the sine of its opposite angle, which is 81 degrees. So here we got the equation, dear students, which has one unknown, y. So we want to solve for it. So again, to solve for y, we just use this cross multiplication. So we will get that sine 57 degrees multiplied by y is equal 8 multiplied by sine 81 degrees. And then to solve for y, we just divide by sine 57 degrees again, and we will get this value. And that will be measured in centimeters if 8 was in centimeters too. That's it, dear students. This is how we solve for y. A little bit more complicated to compare with the example number 1 because this includes 2 steps, but it's pretty straightforward. And now, dear students, I want to work on the last example with you when we will need to recover not the edge, not the length of the edge, but the angle. And let's work similarly, dear students. Let's see which data are we given. So we are given this side and its opposite angle, and we are given this side and we want to solve for this opposite angle. So we now can formulate the law of sines explicitly for our case what we are given. We do not need this angle and we do not need this side to be able to find a, because we are given this data here and it's enough. As I told you, we just need one equation, not 3 or 2. Okay, so let's do that. So we have that 8 over sine a in this case, so we don't know what is a, is equal to 7 over sine 42. And we want to solve for a, dear students. So to solve for a, first we have to solve for sine a because a is hidden under sine. So here we will get that 7 times sine a is 8 times sine 42 degrees. So from this it follows that sine a is equal to 8 times sine 42 degrees over 7. But dear students, we haven't solved for a yet because we have sine a. So how do we solve it? Now we have to solve for a. So to find a, we just need to take the inverse to sine, which is arcsine, and we have to take it to opposites, to both sides, left and right. So we will get that the inverse of sine a will give us just a, and then here we will get arcsine of this expression, dear students. Okay, dear students. So when you will calculate that, so that sine 42 degrees will give you some value, some like a real number, and then you have to multiply it by 8 and then divide by 7, so that will be a real number, and hopefully it will be less than because for arcsine, yeah, it should be like between minus 1, 1. So you will check, it should exist, and then you will take the arcsine of it, and based on that, you will get the measure for your angle A. So the final result will be in degrees, dear students. When you will get the arcsine of this expression, that will give you degrees. And that's it. This is how we found the angle A, how we recovered it using the law of sines. Okay, dear students, so let me repeat what we covered today. So today in this video, we covered the law of sines. So the law of sines helps you to recover the lengths of edges or angles of the given triangle, not necessarily right triangle. And this is how the statement of the law of sines can be formulated. And here is the proof. So you can repeat the same proof for two other cases with this height and with this height to verify this equation and this equation. And these are the examples that we covered. Thank you very much for your attention, dear students.